This is a response to Professor Anton's video, does pi have an absolute value? What a brilliant question. I mean, who knows? I mean, I'm not a mathematician, I know very little about maths. But I love the idea of that, and I love the sentence, does pi have an absolute value? I mean, the reason why I'm liking it is mainly for personal reasons, I suspect, because that part of my head which contains thoughts of value is right now completely colonized with thoughts about moral value. That's because of other discussions I've been involved in, other thoughts I've been having, and particularly when we're talking about moral value, kind of absolute ethics, absolute morality. Does that exist outside of human thought or outside of human existence? Is there just a kind of naturally occurring set of moral precepts in the universe? So that's kind of feeding into my watching of this video on does pi have an absolute value. Some things I'm thinking about is and as I say, I don't really know much about math, but the infinite number. When you try and make a decimal, you try and work out pi, if you like, and work out the ratio of the radius of a circle to its what's it called? Its circumference is an infinite number. It's a non-repeating decimal. But I'm just trying to think what that means, actually. I mean, I guess I'm thinking of it in terms of this book by George Lakoff and Rafael Nunez about where mathematics comes from, which is a kind of cognitive linguistics, embodied cognition take on mathematics, about how maths draws its logic from embodied processes and exists as a series of metaphors, and at least large parts of it exists as a series of metaphors in our minds. And they particularly talk about numbers, and how numbers, which most people think of as the main stuff of maths, but really they're just the kind of foundations. Once you get into maths seriously, numbers are kind of left behind, or don't play such anything like a major role. But number in Lakoff and Johnson is understood metaphorically, even though we don't treat numbers like metaphors, we treat them as solid things. They're understood metaphorically as either objects, so one. And that's kind of how you learn it at school, isn't it? You have a picture book, and there's 1 apple, 2 bananas, 3 giraffes, 4 carrots, whatever it is. So numbers are either objects, or else the other metaphor is points on a line. And again, certainly when my kids were at primary school, one of the ways they learnt number was the number line, points on a line. And those are quite different metaphors, and they work differently, and they allow you to solve different problems if you're working in relation to one metaphor as another metaphor. I mean, one example of that is Zeno's paradox. The paradox where, there's a few variations of it, but Zeno suggests that if you fire an arrow into the air at a target, before it reaches the target, it has to travel halfway, and before it travels halfway to that point, it has to travel halfway there, and before it gets to that point, it has to travel halfway, and there's an infinite series of halfways. And so according to Zeno, the paradox is that because it's an infinite series, an infinite number of small sections of time, it can never ultimately reach the target. Now of course it does, but Zeno's paradox seems to suggest it doesn't. But that paradox disappears if, or the paradox is created by thinking of numbers as objects. So the arrow in flight passes across a kind of series of objects, the object that marks out 1 meter, the object that marks out 2 meters, the object that marks out 3 meters, and so on. That's kind of how you view it. And of course, if you keep stacking up objects in the middle by dividing those distances in half, you end up with what appears to be an infinite series of objects, and that's inconceivable that anything could travel that distance across this infinite series of objects. But if you replace that metaphor with the number line, the problem kind of disappears, because we don't have the same intuitions about lines that we do about objects. And you kind of can't imagine an infinite series of infinitesimal divisions in the line in a way you can't about stacking up objects. So what's that going to do with pi? Yeah, I suppose it's just because we're so used to thinking of objects and numbers as objects that it would be quite interesting, I think, if I don't know if I can get to what I'm thinking of here actually. I suppose that, that phenomenon of this infinite series of decimal points or decimal places after the decimal point in the laying out of pi is because we're talking about what is a relationship a geometrical relationship in terms of objects, and now putting our focus on the object, these numbers as objects. So we're trying to craft a series of objects out of a relationship. We could just as easily do the other thing, if we wanted to. Maybe people already do this, I don't know. We could probably take something like pi, that relationship, and use that as our major focus. Maybe you use that as in the way that numbers are usually considered to be a kind of primary mathematical entity. We could perhaps craft a mathematics in which those kinds of relationships with the primary entities, in which case pi wouldn't be weird at all. It wouldn't be infinite. It wouldn't have any of those qualities. It would just be that there it would be a complete, a primitive, kind of it would have the same status as an integer, as a whole number. It would be a whole relationship. I don't know if that makes any sense at all. Anyhow, thanks very much. And I certainly don't know. I was going to try and talk about moral value in relation to that, but I don't know. I don't know how I can get to that one. Anyway, thanks for posting that curiosity. If I can find a way of talking about morality and pi at some point.